Welcome, everybody, to the latest episode of Star Cells and God. This is the podcast where we discuss new discoveries that are taking place at the frontiers of science and describe how those discoveries provide evidence for God's existence, God's character, and the reliability of Scripture. My name is Fuz Rana. I am a biochemist and a Christian apologist, and I'm joined in studio today by Dr. Hugh Ross, who is also a Christian apologist and an astronomer. We both work for an organization called Reasons to Believe, which is the organization that sponsors this podcast. So if you want to check out Reasons to Believe, go to our website, www.reasons.org, where you can gain access to all kinds of great content describing and exploring the interplay between science and the Christian faith. Also, make sure you follow us on social media, RTB_official. And then last but not least, please go to our YouTube channel where you can subscribe. Our YouTube channel is Reasons to Believe 1. Also, hit the notification button so that you are alerted the next time a new episode of Star Cells in God drops. Hugh, welcome. And today we're going to be talking about a couple of discoveries. One has to do with the cosmic dawn, right? Mm-hmm. And then I'm going to be talking about Human-Neanderthal Interbreeding, everybody's favorite topic. So,
yes.
So Hugh, why don't you go ahead and take it away?
Well, the cosmic dawn refers to the formation of the very first stars in the universe. And, the core of the Big Bang creation model, which the Bible predicted thousands of years ago, is that the universe starts off infinitesimally small and nearly infinitely hot. But as it expands, it passes through a temperature window in which nuclear fusion can occur. So the universe begins with no atoms or molecules. So you wind up very early with just protons and neutrons and other fundamental particles. And you're a chemist. Hydrogen is a single proton.
Yeah.
So the universe starts off with only one element in the periodic table, hydrogen. But as the universe expands from the cosmic creation event, it spends about 20 seconds in the window, the temperature window, of about 14 billion to 150 billion degrees centigrade, where hydrogen can be fused into helium. And during that window, about 24% of the hydrogen by mass is fused into helium, and you get a very tiny trace amount of lithium as well. And so a fundamental prediction of Big Bang cosmology is that the very first stars will have no elements in them heavier than lithium. It's going to be hydrogen and helium, a trace amount of lithium, and nothing else. And astronomers refer to these firstborn stars as population 3 stars, kind of the opposite of what you'd expect. But keep in mind, the first stars astronomers saw were the ones close by, which are the ones that form late in the history of the universe. We call them population 1 stars. Our star, the sun, is a late-born star. It's a population 1 star. As astronomers were able to look farther away, they looked farther back in time, and they saw population 2 stars. But the real quest is to go far enough away we can see population 3 stars. But here's the challenge. The really big stars, stars that are more massive than 100 times the mass of our star, the sun, they form out of the primordial gas clouds literally in thousands of years, just a few thousand years. They ignite the nuclear fusion process in a few tens of thousands of years less, and they go through their entire nuclear fuel in less than 100,000 years. So the most massive firstborn stars literally go through their entire life cycle in much less than 100,000 years. And when they consume all of their nuclear fuel, they explode as supernova. And when they do, they shower the interstellar medium with the ashes of their nuclear burning, which is going to include elements heavier than helium. You're going to get carbon and oxygen, nitrogen, you're going to get iron. That will be spewed out by the biggest of these firstborn stars. Now, the small stars that form at the beginning of the universe, they take like 100 million years to form out of their gas cloud and ignite nuclear fusion. So they don't even get to the nuclear fusion reaction process by the time they're already polluted by the really massive firstborn stars. And so astronomers realize, okay, if we're going to see the ones that are just hydrogen and helium and a trace amount of lithium, they burn up so fast, the only way we can see them is look so far back in time, we're looking at the moment when those firstborn stars actually formed. And not even the James Webb Space Telescope has the power to observe individual stars 13.5, 13.6 billion light years away, which would correspond to 13.5 to 13.6 billion years ago. So everybody thought, well, it's a powerful telescope that's going to do the job. It can see firstborn galaxies, but not firstborn individual stars. Now, how astronomers have dealt with that, they said, well, we happen to be living in one of the oldest galaxies in the universe. And our Milky Way galaxy has had no major disturbance events for the past 11 billion years, which means the outer halo of our galaxy, which is where the oldest stars exist, has been largely undisturbed. Moreover, our Milky Way galaxy is a property that the very distant part of the halo is very underdense, which means the stars are far apart. And so several years ago, astronomers said, wait a minute, we can see firstborn stars, the small ones, in the outer halo, because the stellar density is so small, the stars are all so old, we'll be able to easily distinguish between a firstborn star that's been lightly polluted by the explosions of the really massive firstborn stars and second-generation stars that have been polluted by those stars. And the difference is like a factor of 100 in the iron abundance. So all you do is look for stars that have, say, 1/1,000,000th the iron abundance of our star, the sun. That distinguishes it from the oldest population 2 stars that have got 1/10,000. So literally a factor of 100. And we have found 3 stars in the outer halo of our galaxy that are unmistakable, small mass, firstborn stars. However, astronomers would still like to be able to see the really big stars that are basically nothing but hydrogen and helium and a little trace amount of lithium. Well, the James Webb Space Telescope is not powerful enough to see individual firstborn stars, but it is powerful enough to look far away and see the first galaxies that form. And in particular, a team of astronomers said, let's see if we can find a really distant galaxy where the halo of that galaxy would be big, and just like our galaxy, the halo would be underdense. And they said, maybe we can look at the gas that's been heated up by the firstborn star, because the assumption's been some of those firstborn stars are going to be like 300 to 400 to 500 times the mass of our star, the sun. They'll actually be able to heat up the gas that's going to be forming these smaller mass stars and say, let's actually look at that gas and see if we can see the signature of hydrogen and helium. Okay, well, a candidate, this is a galaxy that was recently discovered a couple of years ago by the Hubble Space Telescope. They could barely detect it. The image that we're going to show here actually is of the, yes, here it is. So here's an image of the very distant universe by the Hubble Space Telescope. And then that little cross mark that you see there, just to the above the inset, that actually shows you where it is, extremely faint, and that's a blow up. And what you basically see there is it's got an extremely bright core ignited by a supermassive black hole. So they use the James Webb Space Telescope to say, okay, this has a good probability of having a big halo. Let's go into the halo where we have gas but not stars and see if we can see the signature that would affirm what the Big Bang creation model predicts. So they looked into that halo, and they were able to use the spectrograph on the James Webb Space Telescope to look at the spectral lines there. And what did they find? they found a really bright helium line, and they looked for metal lines and couldn't find any at all. And they says, wow, I think we really do have some of these pristine gas clouds that are not polluted in any significant way by the firstborn supermassive population 3 stars. So this is the first time that astronomers have been able to actually image a gas cloud or a star where they're seeing hydrogen and helium and nothing else. Now, this is the paper that got published. I shouldn't say published, it's a preprint, but it's been submitted to Astronomy and Astrophysics, which means that it's got a high probability of getting published. The very fact that they were able to say, hey, you know, this is a serious journal that's looking at it. So it's in the peer review process right now. After all, it's based on an image that was recently taken. So this is getting a lot of excitement in the astronomical community. And basically, it's the paper ends by saying, this is an initial study. The James Webb Space Telescope can look at this galaxy to a lot more depth than what was done in this initial study. Can also look at other galaxies like it that are far away. Because what's amazing is some of these very early formed galaxies are actually surprisingly big and bright. And they're basically, this is the best place to find the signature of gas that's nothing but hydrogen and helium and a trace amount of lithium. And so this is exciting news for astronomy. It's kind of the last prediction of the Big Bang creation model to be tested and demonstrated to be right or wrong. But so far, really good news for what the Bible predicted thousands of years ago.
Yeah, so it's pretty fascinating stuff. It's interesting, kind of to me, the scientific workaround. Yeah, how clever the astronomers were in terms of probing for those stars indirectly.
Well, the fact that we're literally living in the only galaxy where it's possible to ferret out these small mass firstborn stars and measure their spectra to enough depth to determine, yes, they're lightly polluted firstborn stars. If we were in any other kind of galaxy, we wouldn't be able to do this. Something described and designed to the core. It's the fact that we have outskirt stars that we don't see in any other large spiral galaxy. So it's like we not only live in a galaxy that's amazingly fine-tuned so that we can exist here and develop civilization, we also live in this galaxy where we can do astronomical research we couldn't do if we were anywhere else. So it's like maybe God had a couple of reasons for designing the Milky Way galaxy the way he did.
Yeah, that's fascinating stuff.
Well, what about this yucky subject that you've got on Neanderthals?
Yeah, and just kind of a fun way to introduce the topic. Recently, I visited my daughter and her husband and my 2-year-old grandson, and it's fun. He's beginning to use some words now and putting words together. And one of his favorite set of words are yummy and yucky.
He knows those 2 words.
Yeah, and so he kind of categorizes his world, is things that are yummy that you can put in your mouth and things that are yucky that you probably shouldn't.
Well, Fuz, I've got to ask you this question. What category does he put you in?
I think I'm in the yummy category.
You're in the yummy category.
Yeah.
That's good.
Well, he likes to give me raspberries. So.
Okay, good.
But anyway, this is his favorite book that it's inspired his categorization by Leslie Petrocelli called Yummy and Yucky. And the whole idea of the book is, again, to help teach little kids those things that should go in their mouth and those things that shouldn't. And just as a spoiler alert, here's a few examples. Blueberries are yummy, but blue crayons are yucky. Spaghetti is yummy, worms are yucky. Burgers are yummy, and boogers are yucky, which is a very important concept for little,
a 2-year-old, yes.
Little Roman to glean. But anyway, my experience, in doing work in science apologetics is that if there's a topic that many people find to be yucky, it's this idea that humans and Neanderthals interbred. And this is disturbing and problematic for many people because they wonder, okay, if humans and Neanderthals are interbreeding, does that mean humans and Neanderthals are the same species? If from a Christian perspective, does that mean that Neanderthals are an atom, just like modern humans are an atom? Are we exceptional as human beings? Or if Neanderthals are like us, were we truly two different species? Were we a single species?
And Fuz, this isn't trivial. There are a number of Christian apologists that are trying to date Adam and Eve before the first Neanderthals,
right,
in order to accommodate some of what is now being published.
Right, and part of that idea is that, well, if humans and Neanderthals interbred, then really we must be the same species, right? And our model is that modern humans, us, are descendants of Adam, and that the other hominins were creatures that were made by God, that existed, that went extinct. They have intelligence, emotional capability, but they lack the image of God. And we would expect some biological differences, but specifically behavioral differences that reflect the absence of the image of God in Neanderthals and
cognitive differences as well.
Yeah. And those differences are going to be primarily cognitive, as you're pointing out. And so
just to be clear, we're saying that Neanderthal is a distinct species from humans.
Yes.
And that Adam gave rise to us, but not the Neanderthals.
Right. So again, there's just a lot of questions that arise. One of them is, how secure is the evidence for interbreeding? And when the claims first came out, really in 2010, I was resistant to the idea of human-Neanderthal interbreeding, in part because of the model that we hold to at Reasons to Believe, but also I didn't think the evidence was that robust, because at that time it was primarily the fact that the Neanderthal genome showed a closer statistical alignment with genomes from Eurasians versus genomes from African people. And so the idea—
We're talking sub-Saharan people.
Yes. Yeah. Thank you for that clarification. And so the idea would be, as humans began to migrate around the world, we would have encountered Neanderthals as we were making our way into Europe and into Asia, and that led to interbreeding, which explains the closer statistical association. That to me felt like a bit of a weak argument. But, since that time, which was in 2010, there's been an accumulation of evidence that, to me, I think really does suggest interbreeding took place. At least I don't know of any other way to explain the evidence other than interbreeding took place. One set of studies that I find to be pretty compelling is the discovery of 3 modern human fossils that date somewhere between 35,000 and 55,000 years in age, in which human DNA was recovered. So we were able to sequence ancient genomes. These are ancient modern human genomes. And it turns out that the Neanderthal contribution is somewhere between 10 to 15% in these genomes, which is what you would expect the closer you are to the point where interbreeding took place.
And say modern Europeans would be at what level?
1 to 4%.
1 to 4%, so this is significantly greater.
Yes.
Another question, do we see a greater similarity when you're looking at, say, the 55,000 compared to the 30,000?
I don't know that level of discrimination exists.
Okay.
Because again, the similarity these are approximate similarity. I don't think
they're talking, 3 fossil finds?
Yes, but the fact that all 3, and these are not complete genomes, but the fact that all 3 show that high of a level of Neanderthal contributions.
Do you know the location of the 3, Fuz?
I do. They actually discussed this in Who Was Adam. Off the top of my head, I don't.
But we're talking Europe as opposed to Asia?
Yeah, these are all European.
They're all European.
These are all European. But also they noted that the sequence of Neanderthal contributions to the genome was longer, had greater continuity, which is what you would expect also closer to the time of interbreeding, because what happens is through recombination, you start to separate regions of the genome from, and that separation would lead to smaller Neanderthal pieces over time. So that data fits. And then there's other things like we've already mentioned. there's 1 to 4% Neanderthal contribution to most human beings' genomes. But that 1 to 4% isn't the same from person to person. And in fact, there's about 20% of the human genome that has Neanderthal sequences in it when you look at the collective genomes within a population. And using a population, again, of collective genomes, you can literally reconstruct about 40% or so of the Neanderthal genome. So to me, the only way you explain all of this data is that interbreeding took place. It just seems to fit. Now, you and I have written about these points and have talked about these points, but there are some things that still are, questions to me. One is the population sizes. The genetic data seems to indicate that Neanderthals formed very small insular populations.
That's especially at the time where humans could have had contact with them.
Mm-hmm.
That's when their population was very low.
Right. And the first humans that were making our way into Europe and in Asia were relatively small groups as well. Mm-hmm. So the likelihood of encounters, to me, seems to be relatively low unless humans and Neanderthals were somehow attracted to the same landscapes, because of the resources. If there are places that are rich in resources, you may end up attracting these groups to those places. So, to me, that may be one way to, explain the unlikelihood of encounters. Another problem is why wouldn't humans and Neanderthals try to avoid each other, right? There's no reason to think that if you saw groups of people that were different than you, that you would seek to avoid them as opposed to interact with them. And then there's also some significant developmental differences in the way that Neanderthals went from birth to adulthood compared to humans. And the question is, does that difference in development factor into the likelihood of interbreeding?
I've heard you say it's about a factor of 3 in timing, like for humans, 25 years.
Yeah. For
Neanderthals, 8 or 9.
There's some data that suggests Neanderthals had a very short adolescence, mm-hmm. right? And again, that suggests some differences in developmental trajectories. So those are outstanding questions. And so, again, these are some of the questions that arise. Were humans and Neanderthals the same species? How could humans and Neanderthals interbreed? And then, of course, theological questions. Did humans and Neanderthal bear God's image? Did the hybrids have the image, or did Neanderthals have the image of God? Did the hybrids have the image of God? And one thing to point out is, even though people have this common perception that species form this interbreeding population, that is called the biological species concept. It's not the only species concept. And in fact, we know of a large number of instances where different species will actually interbreed and will not only produce viable offspring, but offspring that are actually capable of reproduction. In fact, some time ago, I talked about a discovery on Star Cells and God. Maybe Jeff was on the show with me, where we talked about polar bears and brown bears hybridizing.
Right.
And that was really critical for the survivability of brown bears during the ice ages, when climatic change was rather significant and severe in some cases, where the brown bears picked up genetic information from polar bears that helped them to survive in more inclement environments. So it is something that is widespread. So just because interbreeding took place doesn't mean that they were the same species.
Or does it mean that the two species will merge?
Right. And they clearly remained distinct, right? And so that means the interbreeding must have been relatively limited. Otherwise, if it was extensive,
you would get a merger event.
That's a really good point. Now, from our model, from a creation model, we look at shared similarities in humans and other creatures, including Neanderthals and the great apes, as reflecting common design, not common descent. So you could argue that because God created humans with shared biological features with the other hominins, that interbreeding is actually possible. Now, from a theological standpoint, and I've written some articles about this, and we discussed this in Who is Adam, just because the humans and Neanderthals interbred doesn't mean the hybrid would necessarily lack a soul or lack the image of God. There are different models of ensoulment that Christian theologians have proposed, and we don't need to get into them here. But in both sets of models, it's possible to conceive of scenarios by which the human-Neanderthal hybrids would retain the image of God. I just don't see the image of God as divisible. So if one of the parents has the image of God, you could argue that the offspring would too have the image of God. So there's no reason theologically to think that would be necessarily an issue. And something else to point out is there are anthropologists who have studied, the nature of these human Neanderthal hybrids and have concluded that they probably had poor fitness, that they were just on the cusp of survivability and just on the cusp of being able to reproduce. And in fact, there's seems to be evidence that these hybrids that were primarily female, there's no evidence for Neanderthal contributions to the Y chromosome, which means either the males weren't able to reproduce or they didn't even survive. So this is, supports the idea that really humans and Neanderthals are separate and distinct species.
Well, also the idea that the interbreeding couldn't have been very significant.
Yes, that's exactly right. Now, and from a theological perspective, you could take the view that, while this is not something that pleased God, or this is not what God would have wanted, that God still could use this as a way to help humans to multiply and to fill the earth. Because as humans were going into places in Asia and Europe, the climate now was very different than what they would have experienced near the equator, which is where humanity originates. And so the Neanderthals and the interbreeding with Neanderthals could have introduced genes into the human gene pool that allowed humans to survive colder environments, allowed humans to more successfully fend off pathogens that they never would have encountered. So that which we intended for evil, God was able to use for good.
And interbreeding is actually mentioned in the Bible. You got it in Genesis 6:3, talking about the sons of God having intercourse with the daughters of men. And then look at all the prohibitions in the book of Leviticus against bestiality. So evidently this is something that God was aware of would tempt human beings, and he actually addressed it. And also, he wasn't for it. What you see in Leviticus is extremely strong prohibitions against bestiality, which means God knew that there would be risks.
Yeah. Well, the paper that I want to talk about, the new discovery I want to talk about, builds off of this idea that these human Neanderthal hybrids were again something that maybe God didn't intend, but and that there were protective mechanisms that God put in place to ensure that those features of our physical makeup that support the expression of the image of God were not tarnished by the interbreeding events. And this is a paper published, about a year ago now, a little bit over a year ago, by a team from Spain. And I've been wanting to talk about this, and it's just never made it to the top of the stack. And so I'm glad I have a chance now to discuss this. But this is, again, talking about something that is rather interesting about human and Neanderthals and the contribution of Neanderthals to human genomes. There are places in the human genome that are called gene deserts, these Neanderthal gene deserts. The four largest ones are of significance because they actually include genes that are associated with language capabilities, like the FOX2P gene and other genes like that. There's also genes in these regions that are clearly involved in neural development. And so you could argue that there must be some mechanism like natural selection that's preventing any Neanderthal contribution to these regions of the genome. Or if there is a Neanderthal contribution, it gets cleaned out very quickly just through the process of natural selection. And so, if you think of the image of God as being, again, a quality that is a immaterial quality, a spiritual quality that then is manifested through, in a physical way through our behavior, that means there's got to be brain structures in humans and Neanderthals that are different that, would support the image of God in modern humans and would be consistent with the absence of the image of God in Neanderthals. And so it looks like indeed there are these regions that somehow are being protected, that this is actually a mechanism that maintains a species barrier between humans and Neanderthals, preventing them from actually merging into a single population. And so in this study, the researchers wanted to study the genes in these Neanderthal gene deserts. And so what they did is they looked for differences in gene expression in these gene deserts versus corresponding regions in the genome where there weren't Neanderthal gene deserts that are about the same size, roughly the same gene density. They also were focusing on genes that experience positive selection, which means that those genes are playing some kind of critical role. And they used the Allen Brain Atlas data to look at how gene expression varied during the course of development and also how it varied from brain region to brain region, where they gave specific emphasis on the thalamus, on the striatum, and on the cerebellum. These are parts of the brain that are kind of integrating information within the brain. And what they discovered is, long story short, is that there is significant differences in gene expression patterns in these regions for those genes that are under positive selection, that they show divergent expression compared to corresponding gene regions and corresponding brain regions or other tissues in the body. And so this really suggests that there is indeed a protective mechanism that retains our identity as humans, particularly with respect to our cognitive abilities. But one of the things that I also thought was interesting is that the authors of this paper actually argued that this work is evidence for human exceptionalism, that work is evidence that there is cognitive differences between humans and Neanderthals, and that again, this is a reproductive barrier that's maintaining the distinctiveness of modern humans. And so ironically, for many people, the idea that humans and Neanderthals could interbreed undermines the notion of human exceptionalism.
Wow.
And so these authors are saying, wait a minute, the human-Neanderthal interbreeding actually, when we dig into it a little bit deeper and look at the specifics, actually evinces the opposite. It actually provides reason to think that humans are actually exceptional, because why else would you preserve those regions of the genome, as being distinctly and uniquely modern human in character?
Well, what I like about this, Fuz, is like God anticipated that we would sin. And ahead of time, he designed our genome and our body in such a way that in spite of our sin, the human distinctiveness, the human image of God would be preserved and protected.
Yeah. Exactly. And I think that's really interesting. But again, it means that, that humans and Neanderthal interbreeding is a bit yucky. It's disturbing. It's disgusting for a lot of people, but it doesn't undermine the RTB creation model in any way. In fact, ironically, it supports our creation model and our perspective on Neanderthals, and allows us to see that interbreeding as, again, something that God could take that which is evil and turn into that which is good.
Kind of like the story of Joseph and his brothers.
Right.
So,
yeah.
But you're also making the point that, hey, the interbreeding is rare.
Yeah.
It's not something that's common. And I've heard you say, too, that we see in that genome contribution, it has zero impact on the behavior of humans and zero impact on the anatomy.
Right.
So the distinctive behavior of humans relative to Neanderthals in no way was interrupted by the interbreeding,
Right.
and likewise the anatomy.
Right.
And, I think that's where you got a consensus. The anatomy of humans, the anatomy of Neanderthals is distinct by multiple pieces.
Yeah.
I remember when we first started Reasons to Believe, there were anthropologists saying that Neanderthals were anatomically identical to humans. I don't know anybody that's saying that anymore.
Yeah, yeah. Well, Neanderthals had what are called hyperpolar body designs.
Right.
They were ideally suited for cold weather environments, whereas we as modern humans are not. And over time, as humans have populated different parts of the world, through natural selection, our bodies have become more polar adapted for at least people in northern latitudes. But even then, those body designs are still not
distinct.
not like Neanderthals in terms of their hyperpolar design. Okay, well, that's all I have. So ready to bring it all to a close. I just want to say thank you so much for watching this episode of Star Cells and God. Would love to hear your thoughts, your comments on the discoveries we discussed. So please put them in the comments below. We look forward to hearing from you. And also remember to go to our YouTube channel and subscribe, Reasons to Believe 1. Also use the notification button to alert you when the next episode of Star Cells and God drops. That would be every Wednesday. And also you can find Star Cells and God on your favorite podcast app. Don't forget to follow us on social media, RTB_official. Check out our website, reasons.org. Share this video with a friend. And remember, the more that we discover about science, the more we have reasons to believe.